In this video, we'll be talking about some vocabulary that goes with circles. So circle vocabulary here. So first, let's define what a circle is. A circle is just all the points in a plane that are the same distance from a given point. So we have the center of the circle, and then it's all the points that are like 2 inches away from that center. Then all these other vocabulary words are going to kind of be embedded within the idea of what a circle is. So the first thing is a chord. A chord is a segment that has both endpoints on the circle. So if you're looking at this example that I have drawn here, this line AB, this segment is a chord because both A and B lie on the outside of the circle. The next is a diameter, and a diameter is just a special type of chord, and it's a chord that passes through the center of the circle. So I'm going to go ahead and highlight in blue the center of the circle. So any chord that passes through the diameter, that passes through the center, is going to be called a diameter. The next is a radius, and people often think of the radius as half of a diameter. Basically, a radius is a segment that starts at one endpoint of the circle, that starts at the circle and then goes to the center of the circle. So any segment that's starting at the center and going to any point on the outside of the circle is going to be a radius. So you've probably heard of all of those vocabulary words before, actually. Here's some potentially new ones. A secant. A secant is a line, so not a segment, but a line that goes on forever, that intersects a circle at 2 points. So any line that's going to touch our circle at 2 points, like in this case at EF, is going to be called a secant or a secant line. One thing really fast that I want to point out is just some difference in the notation. Notice that when I talked about radii or a radius, I said CD is a radius, and I used just like a solid line above the CD to indicate that it was a segment. Notice how I changed that down here. Since a secant refers to a line, I have those little arrows on either side of the line above the EF to indicate that I'm talking about a line and not just a segment or a portion of a line. Okay, so let's talk about a tangent. This is going to be one of the most important ones for us. A tangent is a line in the plane of the circle that intersects or touches the circle at exactly 1 point. So you can see a picture of this down here. I'll put a star next to it. That line that's touching the circle at exactly 1 point, that would be a tangent line. With tangent lines, we care about what's called a point of tangency. So the point of tangency is the point where the tangent actually touches the circle. So in this case, we would say that, like in this picture down here, we would say that line L is tangent, and then this point G is the point of tangency. Okay. We can also talk about a tangent segment, which would be a segment that touches a circle at one of its endpoints and lies on a line that's tangent to the circle at that point. So basically it means that you took a tangent line, maybe I'll just draw one in dotted blue, and you just took a section of it. So MN is kind of like a section of a tangent line. We call that a tangent segment. And again, note that when I'm talking about segments, the symbol I use is just a horizontal line over the 2 endpoints of the segment. So let's do some practice naming some of these things in a circle. So here we're going to look at circle P. This is an important thing to know, is that we call our circles based on their centers. So we're going to look at circle P, and we are going to name all of these different segments, lines, and points based on this circle. So start by looking at segment AF. So A and F both lie on the outside of the circle, and the segment passes through the center, which means that AF is a diameter. Okay, let's look at EG. So EG has 2 points that lie on the circle, and they do not pass through the center. So this is just going to be a chord. PF, so P is the center and F is a point on the outside of the circle. So PF is going to be a radius. And PG is also a radius because the endpoints of that segment are the center of a circle and then a point on the circle. So note that there can be like multiple radii, that's the plural of radius, inside of a circle. There also can be multiple chords and diameters. Let's look at point C. So looking at point C is a point of tangency, which means that at point C, there's a tangent line that passes through, that hits a circle at one point. And let's actually look at that tangent line. So that tangent line is this line that contains point C. So it's line BD. So let's actually name that right now. This line BD would be tangent to the circle. Now the line CE, which is the one that we skipped, that's a line that touches the circle at exactly 2 points, which makes it a secant. Now you'll notice that the line CE also passes through the center of the circle, but since it's a line, it is not considered a diameter. It's just a secant. If it's a line, it can't be a diameter. Only segments can be diameters. Okay, and then my final one is point P. This one's probably the easiest one. We actually started by talking about this. Point P is the center of the circle. It's kind of what everything in the rest of the circle revolves around and is centered on. Let's go ahead and do the same thing with this next section. What we're going to do is we're going to look at circle Q over here on the right, and we're going to identify all of these different things. I'm actually going to hit pause on my video. You hit pause as well. Fill in examples of all of these different vocabulary words, and then come back on and check your answers. All right, here's what I found for some examples of chords, radii, tangents, diameters, secants, and points of tangency. One thing I did wanted to point out, first of all, note that my chords, radii, and diameter are all segments. My tangents and secants are all lines. Okay. The next thing that I wanted to just point out is that you may have gotten slightly different answers than me. So for example, maybe for your radii, you put PQ instead of QP. And that's okay. The important thing when you're naming segments and lines is that you're talking about and listing both points. The order that you put the points in doesn't actually matter. When we get into angles and talking about angles and arcs, that's when it is going to matter, the order that you go in. But when you're naming segments and lines, the order you list your points does not matter. Okay, let's go ahead and talk about some angles and arcs then. So the first thing we're going to talk about is called a central angle. And a central angle is an angle in a circle whose vertex is the center of the circle and whose sides are radii of the circle. So let me just draw a picture of that really fast. So we have some circle, and we need the center, and the vertex of our angle is at the center. And then the sides of our angle are radii. So this blue angle that I just drew, let me mark that a little bit better. That is a central angle. It just means that the angle lies at the center of the circle. Now, whenever you create a central angle, you're also going to create two different kinds of arcs, a minor arc and a major arc. So the minor arc is all the points on a circle that lie in the interior of the central angle. So you can see that picture down here, put a little star next to it. It's highlighted in red. So we're just looking at the points of the circle that are kind of in the smaller section of the circle that the angle made. When we name minor arcs, we're going to use this nice little like swoosh symbol above the points. So I'm looking at the arc that starts at A and ends at B. So we're going to put the little kind of swoosh over it and connect those 2 points A and B. Another important thing is that minor arcs measure is less than 180 degrees. Okay, so think about your minor arc as the smaller chunk of the circle. The major arc would be kind of the opposite. It's the bigger chunk of the circle. So over here on the right, you can see an example of a major arc highlighted in red. So we're looking at the same central angle, but now we're looking at all the points that are kind of outside that central angle or not part of the minor arc. Now, when we name major arcs, we're actually going to use 3 points. So notice that in this picture, I have this extra point D down here. And so when I name this major arc, I'm going to kind of start at A, or I can start at B. And I'm just going to go around and list A, D, B. Those are the 3 points that kind of create my major arc. You could also list them as B, D, A. The important thing is that you're going in an order. So now why should we even care about central angles, minor arcs, and major arcs? The cool thing about them is that they're very much related to each other, very, very similar to each other. So first thing to know is that we measure angles, of course, in degrees. We're also going to measure both minor and major arcs in degrees. So if you're looking at a measure of a central angle, that's the measure of the angle. Okay, so you're just looking at that angle that's at the center of your circle, and that would be the measure of the angle. The measure of the minor arc is the same as the measure of the central angle. So once you know the central angle, you know the measure of your minor arc. And then to figure out what your major arc is, you would take 360, which is the whole circle, and then subtract just the angle of the measure of the minor arc. So the idea with finding the major arc is that both the major arc and the minor arc together make a full circle, which we know is 360 degrees. So if you kind of think about taking away the minor arc to get the major arc, you got to figure out what's left over from 360. So let's do some examples here. So in this circle, I have a 100-degree central angle. So the measure of my central angle is 100 degrees. The measure of the minor arc, I'm actually going to highlight the minor arc in red for us. That's going to be this arc right here, BD. And the measure of that angle is 100 degrees. Or sorry, that arc is 100 degrees. It's the same as the central angle. And let's go ahead and name that minor arc while we're here. So just shift right over to the right here. We can name this minor arc in two ways. We can name it arc BD, or we can name it arc DB. So the important thing is that you have both endpoints of your minor arc listed. Let's actually jump back to the central angle because we forgot to name it. The measure of a central angle is 100 degrees. To name the central angle, we're going to need 3 points. And we actually forgot to label the center of my circle. So let's just go ahead and label it A. So the name of my central angle is going to be angle BAD, or I could also name it the other direction, angle DAB. Okay. The important thing is that A is in the middle because the A is the vertex of the angle. All right, let's go ahead and take a look at the major arc. I'm going to highlight the major arc in green. So the major arc is basically all this other portion of the circle. To figure out what the major arc is, how many degrees it is, I'm going to do 360, and I'm going to subtract the minor arc. So it's minus 100 degrees, and I get 260 degrees. So that 260 is the measure of that major arc. When we name the major arc, remember we want to go in order, and we do need to include 3 points. So we could name it as arc BCD, or we could go the other direction and label it as arc DCB. And again, the important thing to remember here is that the C needs to be in the middle because it's in the middle of the arc. The B and the D are the endpoints of the arc, so they need to be at the beginning and the end of the name of the major arc. So let's jump into some maybe specific examples and just some more practice with these things. There's a special thing that we call a semicircle. I'm sure you've heard of this and you know what it looks like. Here's just more of a mathematical definition of a semicircle. A semicircle is an arc whose central angle measures 180 degrees. So basically it means you're chopping your circle in half. So let's go ahead in this next example. We are going to name some major and minor arcs and the central angle and find the measure of each. So in these examples, I am only going to name the arcs and the angles in one way, but just know that you can do the rearranging that we talked about up here if you go in a slightly different order. So let's start with the central angle. So remember, angles always have this angle symbol in front. And you know what? We forgot to label the center of the circle again. So let's name it C for center. So angle QCS is going to equal 45 degrees. Then let's look at the minor arcs. Remember, the minor arc is this little portion between or kind of within the central angle. And we name the minor arcs with just 2 letters. So arc QS would also be 45 degrees. And then to get my major arc, I've got to include that middle letter. So QRS, that's the bigger chunk of the circle. To figure out what that angle is, I need to do 360 degrees minus 45 degrees, which is equal to 315 degrees. So that's the measure of my major arc. Now notice that I didn't label any of these things as like central angle or major arc or minor arc. Just by the symbology that we're using, you can tell what we're talking about. So notice that this first piece, when I did the central angle, I used an angle sign, so I know that's a central angle. In this next piece, I had an arc sign, and I only used 2 letters, which means I know it's a minor arc. And then in this next one, I used an arc sign, and I used 3 letters, which means I know that it's a major arc. So that's one of the benefits of using and being familiar with math notation is you don't have to write out a bunch of words if you can just use the notation. All right, let's go ahead and do the same thing with the next one. In fact, let's name this central angle Z. Hit pause, do this on your own, and then come back and check your answers. All right, hopefully you were able to get those same answers as me, but with maybe perhaps a different order of your letters. All right, so now what we're going to do is we are going to kind of just fill in a bunch of information about a bunch of different arcs in this circle. So one thing that we're going to start with knowing is that AC and BD are both diameters, which means they are passing through the center of the circle. So let's start with the measure. So this M in front, that means the measure of DC. So I'm looking at this measure of DC. I want to know how big is that arc. What I would like to do is if I could figure out the measure of this central angle, then I know it would equal the measure of the arc. Now I don't know the measure of this central angle of angle DFC, but I know that the angle across from it is a 35-degree angle. Now if you remember that these 2 angles are vertical angles, which means they're congruent. So that central angle is also 35 degrees, which means that the measure of arc of the minor arc DC is 35 degrees. Okay, let's go ahead and look at B. So the measure of arc BC. Let me switch to red. So now we're looking for the measure of this arc right here. There's a couple different ways of thinking about how to figure out what this is. What we really need to do is figure out what this central angle is that I'm highlighting in red. Now what I'm going to do is I'm going to use the fact that I know that BD is a diameter. So BD, I'm going to put in a dotted line. Hopefully all these notations are helpful and not confusing. So BD is a diameter, which means it's 180 degrees. And I know that BD is composed of 2 angles. The angle that I'm looking for, that I've highlighted in red, and that little angle that I just decided was 35 degrees. So if I wanted to figure out what the measure of just the arc BC is, I could just subtract the 35-degree angle that's kind of already part of the diameter to get 145 degrees. So that red angle in here is 145 degrees, which means that this portion of the circle is also 145 degrees. All right, let's go ahead and talk about the next one. I'm going to erase all these markings that I've done over here. I'm just going to fill in kind of the things that I've already decided. I decided that this angle was 35, and I decided that this angle right here, I'll just put it out here, is 145 degrees. Okay, so the stuff in black is the stuff that I've learned based on the first 2 problems that I've done. So let's jump to example C. In example C, we're trying to find the measure of the arc CDE. So I'm going to start at C, pass through D, and then go all the way to E. So I'm going to figure out how long is that arc. Now I know what part of that arc is, because the part of the arc that has the C and the D in it, that's 35 degrees. But I don't know what this other little chunk is. So what I'm going to do is I'm going to use the fact that all of the angles in this circle are going to add up to 360 degrees, because 360 is a full circle. So I'm just going to start adding up all the angles that I have, or that I already know in my circle. So I'm going to say, okay, 92 degrees, plus 35 degrees, plus 145 degrees, plus 35 degrees. What's that? I'm going to grab my calculator really fast. That gives me 307 degrees. And that's actually the entire circle except for this little chunk right here, the chunk from the arc ED. So let's just figure out what that is by doing 360 degrees minus 307 degrees to give me 53 degrees. So now I know, I'm going to fill this in black, that this angle right here is 53 degrees. So if I'm looking at the measure of that whole arc from C to D to E, I'm really looking at the angle EFC, which is a 53 degree angle, plus the 35 degree angle, which gives me an 88 degree angle, which gives me an 88 degree arc. Yikes, that took some time. It was pretty simple, but it did take some time. However, I think that now as we move forward, we have filled in so much information about the circle that the rest of these should go fairly quickly. Let's say I want to figure out what the measure of arc DE is. That one's easy. We already figured that out because we know what the central angle is. So we know that the arc is 53 degrees. Okay. Now let's look at, get rid of this blue, the major arc ABE. So this is going almost all the way around the circle. What I'm going to do is I'm just going to take 360 and I'm going to subtract 92 from that because that's the only portion of the circle that we're not including in the major arc. So 360 minus 92 is going to give me 268. And that's the measure of that major arc. Now the next arc that we're going to look at is actually very similar. It's arc A, whoops, I forgot to switch back to blue. It's arc ABD. So with that arc, I'm getting almost all the circle. So I'm going to start with 360, but I'm not including the 92 degree angle or the 53 degree angle. So I'm going to take 360 minus 92 minus 53, and I get 215 degrees. So that major arc is 215 degrees. Now, just so you know, as I work through these, maybe you got the right answer, the same answer as me, but you worked through it a different way. There are several different ways of thinking about these kinds of problems. So the important thing is that the way that you're thinking about it is mathematically correct and that you are landing on the right answer at the end. All right, we've got one other type of angle to talk about, and that is an inscribed angle. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So maybe that sounds a little complicated. Basically what it means is that your angle, like the end of your angle, is sitting on the outside of the circle. Whenever you have an inscribed angle, it's going to create what's called an intercepted arc. An intercepted arc is the arc that lies in the interior of an inscribed angle and has endpoints on the sides of the angle. And you can see this picture over here. The inscribed angle would be this red angle right here. And then the intercepted arc is the part that's highlighted in blue. Now, just as a warning, we talk about inscribed angles and central angles all the time. You want to make sure you don't get them mixed up. So an inscribed angle is always going to be like on the outside of your circle. The angle is going to sit on the perimeter of your circle. And then the central angle means that the angle is opening up at the center of the circle. So we learned a lot of cool things about central angles. Let's talk about some cool things about inscribed angles. One of the coolest things about an inscribed angle is that if an angle is inscribed in a circle, then its measure is half of the measure of its intercepted arc. Okay, so let's just look at an example of that. Let's say I have this inscribed angle AGB. And let's say that the angle is, I don't know, it looks like maybe 50 degrees. Okay. If that is 50 degrees, that is exactly half of the measure of the intercepted arc. That means that the intercepted arc is going to be 100 degrees. You can see this example on the right as well. If I have this intercepted angle that's 60 degrees. The inscribed angle is 60 degrees. The intercepted arc is 120. I also have something else drawn in here. I kind of drew in a dotted line this other angle, which is a central angle. So we know that if we had a central angle that were to start and end at A and B, it's going to have the same measure as the arc out here. So just by knowing the inscribed angle, you can get the intercepted arc, which can work backwards to get you that central angle. So let's do some practice with that. Find the measure of the inscribed angle or the intercepted arc. So let's say I start with the angle. The angle is 72 degrees. Then the arc over here, the intercepted arc, DF, is going to be twice that, which is 144 degrees. Okay, let's say I start the other way. Let's say I start with the arc, and I know the arc is 42 degrees. Then the angle is going to be exactly half of that, so it's going to be 21 degrees. And maybe we want to write this out so we can practice writing out angle JKL. The measure of angle JKL is equal to 21 degrees. Okay, let's look at this last one. So I have this inscribed angle. It's a really big angle, 112 degrees. And I want to know what this intercepted arc is. So the intercepted arc, remember, is always twice the inscribed angle. So I'm just going to do 112 times 2 to get 224 degrees for that arc. Now this arc is a major arc, so let's go ahead and name it really fast. XWZ. The measure of angle of arc XWZ is going to equal 224 degrees. So hopefully these exercises were helpful in helping you become familiar with central angles, inscribed angles, and then some of the cool theorems that come along with them.